professional skills, but that wasn't as important, so I won't be going over that today. But then we had physiology and histology, of course, we have that every day. Then we had epidemiology, then we had anatomy. So, let's go ahead and get started. Okay, so neurophysiology is what we were talking about yesterday, and okay, so like neurons and action potentials, and we went over this a little bit already. So we're going to talk about the basic unit. How does a nerve cell transfer information? How are they organized to do their job, those cells? And then how do the various nerve arrangements function together? So, the purpose of the nervous system is for movement, secretions, visceral responses, perceptions with actions, basically. It's a network of neurons. There's the central nervous system, the peripheral nervous system. The peripheral nervous system has visceral responses and somatic responses. Basically, the central nervous system is the brain, spinal cord. The PNS, peripheral nervous system, is everything else, pretty much. Everything that's not in the dura mater, everything that's outside of the blood-brain barrier. But then there's the autonomic nervous system, which controls automatic responses, basically. So the primary cell is the neuron, of course, but then there's astrocytes and micro or macroglial cells. Those are the supportive cells of the nervous system. And then there's dendrites of the neurons. Those increase the surface area and connect to other neurons for synapsing. Okay. Again, the central nervous system is like the brain, spinal cord. So part of the brain is the cerebrum, cerebellum, brainstem. It's limited though because it's encased in dura mater, like I said. Hey, how's it going? And it's protected by the blood-brain barrier. But the peripheral nervous system is outside of the dura mater and outside of the blood-brain barrier. Not sure if they're the same thing. I don't think so, because they were mentioned separately. But anyway, the dura mater is like a fibrous connective tissue surrounding the brain. The blood-brain barrier is, it keeps certain stuff out of the brain that doesn't need to be there. Yeah, we kind of already talked about this a little bit. So the central nervous system has a motor cortex, a temporal lobe, and a reticular activating system. The temporal lobe is for balance. Hey, Andrea. The reticular activating system is kind of what keeps the brain active, I guess. Turns it on, if that makes sense. And then the PNS, peripheral nervous system, is sensory afferent and motor efferent, voluntary. And then the autonomic nervous system, again. And apparently the autonomic nervous system regulates visceral function. So again, neurons, Neurons have action potentials and they have a unidirectional signal, and they communicate through synapses via chemical neurotransmitters. And then the support cells have no action potentials. These are things like oligodendrocytes in the CNS or Schwann cells in the PNS. And then these things, some of these things can make myelin for the for the axons of neurons, certain neurons. Hey Zane. And then astrocytes are another type of support cell. Then there's the microglia and enteric glia, and then satellite cells. The primary cell, again, I've already said this like twice, it's repeated, but it's important. The primary cell of the central nervous system is the neuron, because it generates an action potential, which is an electrical signal that carries information. No other cell in the body can generate electricity or an action potential. These neurons connect functional areas of the brain and spinal cord to each other and to effector organs, bundles of axons which travel together and they form pathways through the brain and spinal cord. So a group of axons of similar function form a tract, hey Livia, in the brain and the spinal cord. A group of tracts in the spinal cord form long columns called funiculus, or funiculi. Funiculus is singular. And then the accumulation of cell bodies of similar function in the central nervous system is called nuclei. That's the plural. Nucleus is singular. Yes. So sensory nerves are bidirectional and they're not myelinated. The axons are not myelinated, but myelinated nerves are usually going to be motor nerves, and they're unidirectional, meaning one directional. They've only got one direction they're going. They're going toward the muscle or whatever they're innervating, while the sensory nerves need to go both ways. Okay, and then there's something called neural modalities. This is referring to the type of information that a neuron transmits. It's characterized by three things: the direction of information flow, the anatomic distribution of the information flow, and then the information flow on basis of embryological origin. Okay, so direction of information flow is like, again, afferent, which is sensory nerves, go both ways, and then efferent motor nerves go only to the muscle, or to the thing you're innervating. And then there's visceral, which is like going to organs. This is the anatomic distribution of the information flow. Then there's somatic, which is non-visceral, like skeletal muscle, skin. And then there can be the information flow on basis of embryological origin, special nerves, going to sensory organs like your nose, your ears, stuff like that. Then there's those special nerves can also go to the branchial arches, which form different parts of the head during embryological development. So branchial arches, there's 12 of them during embryological development, whenever you're an embryo. And yeah, interneurons connect nerve cell pathways to each other, and yeah, this is if this is kind of confusing, don't worry, I'm confused too. So why are classifications important? It's because anatomy and disease are linked. Something's wrong, it's most likely due to something being wrong in the anatomy, right? So, when you see something wrong neurologically, you gotta ask, is it a neurologic impairment? Like what is where is the trauma or whatever? Where is the tumor? If it's on the brain, then yeah, there's probably some brain issue. What part is diseased? What diagnostic test should I use, etc. Again, the effector organ is the organ getting activated. Blah 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 blah. A synapse is where acetylcholine gets transferred from an axon terminal to the postsynaptic membrane. Yeah, okay. We're done with physiology and histology. Okay, next is epidemiology. I have a feeling there's not going to be too much to talk about today, because then in anatomy, it's all reproductive stuff, and I don't want to get banned off YouTube, so I'm not sure if I can talk about that too much. Or I might need to have like an age restriction or something. But anyway. Okay, so evidence-based medicine, not all statistically significant findings are clinically relevant. But not all clinically relevant findings are statistically significant at the same time. For example, well, okay, and let me go in a little deeper into that. So, small differences may be found in a statistically significant study that would not change your clinical judgment, and at the same time, things that could or would change your clinical judgment might not be statistically insignificant, or might not be statistically significant. Like, the carnivore diet is a perfect example of this. There's tens of thousands, hundreds of thousands, millions of anecdotes, which means just someone sharing their story, of people healing their chronic health issues, and other things by just eating like meat and eggs, and that's it. Water, meat, eggs, or meat and water and salt. And that's it. Doing that for like months. Good afternoon, Linda. Hey, Nikki Hulse. Do I believe it? What is it? The carnivore diet? Yeah, I do it myself. I've been eating carnivore for almost 3 years now. And I mean, I don't know if I don't feel unhealthy. I do feel unhealthy whenever I go off of it, like if I go to Brahms and eat some ice cream or something like that, but there's also, but that's not statistically significant because there's not enough research on it yet. And so clinicians are like, oh, yeah, I don't trust it because there's no research. Well, it doesn't matter if there's no research. If it works, right? And so it's not statistically significant, which is what I'm talking about here, but it's clinically relevant. And so people could, or animals as well, because dog and cat digestive tracts are very similar to ours. Not the same, but very, very similar. Hey, Sia, I'm not sure if I said your name right. But, what was I saying? Yeah, like, still, these animals, these people can get benefit from doing these things. Um, my sister was vegetarian for many years and she always looked sleepy and was sick more. Sorry to hear that. Yeah, I mean, unfortunately, well, I mean, let's talk about why. So, what are the components of vegetables? Well, the most prevalent component is fiber, right? Doctors are always saying, oh, you need your fiber. It's an essential nutrient, right? Well, what's so essential about it? Because all the nutrition classes I've been through, and I've been through three in the past 2 years, I think, maybe three in the past 3 years, told me that pretty much every animal that has one stomach and is not a hindgut fermenter, which means they don't have a giant cecum. Horses have giant cecums. Guess how big our cecum is? About the size of your pinky finger. It's called the appendix now, as a matter of fact. It's vestigial. People get it removed, and they're still fine. If if we've got a cecum that big, this is the amount of um, fiber digestion we have. So doctors are like, yeah, you need fiber to keep you regular, which means to poop more. Why should we want to poop more? Good point, Nikki. Why should we want to poop more? Why do we need more waste in our bodies? If we're not using the thing, get rid of it, right? And that's what I did, and I don't have any problems. I still poop because I still produce waste, because meat and eggs are not 100% digestible. They're about 90 to 95 or 98, I don't know, something like that. But yeah, oh yeah, there's many things we can. There's just a lot of nuance in medicine that a lot of doctors ignore because they feel like they don't have time, they're lazy, um, they don't care, or they truly do care and they just don't know yet. So, okay, so, yep, statistical significance doesn't necessarily tell you some things. Like, just because there's an association does not mean there's a causation. There's always biases, and there's always error, either random or systematic. So, random error can be estimated, but cannot be eliminated. And there's something called confounding, which is where you unintentionally add an extra independent variable, aka the variable you change, but I mean, you didn't want to, it was unintentional, right? That's confounding. For example, let me find an example here. If I were to have a study where, okay, well, here was the example. So the study was, well, I'm not going to use this example. This one's kind of confusing. I don't know. It's those examples aren't very good. The You could have a confounder. All these nutrition. I'll just use nutrition as another example because that's a really convoluted, or can be convoluted topic. For example, if we say, "Oh, seed oils are good for you because we've got this poorly created study over here that says so." Well, we've got to take into account that not everyone in the study is the same, right? Different ages, different genders, male and female, different, um, not culture, but different genetic makeup, right? All these people come from different parts of the world. They've got some genes in them that are better acclimated to eating plants than these people, simply because they've been doing it for a little bit longer than these people in their ancestral history. Or you could already have people that are obese. And if you're studying on them, that can be a confounder. Because if you do a study on a healthy person versus an obese person, of course there's going to be confounders. Their metabolic states are different. Their health status is different. Their weight is different, of course. So, yeah. Epidemiology, it's a breeze so far. I'm having a lot of fun. But that's pretty much all there is for that day. And then, of course, anatomy. I mean, again, I can't really talk about this because it's a lot of reproductive organs. Wish I could, but, well, I mean, I probably can, but, hey, Danica. I probably could, but I have to make the stream, like, I don't know, for a more mature audience, and there's a lot of kids who watch this, so I'll just hold off on talking about this, but maybe one day I'll mention all this stuff. I don't know. Not all of it's like, it's not graphic or anything, it's just using a lot of terms that people, immature people, could be like, he said it, he said the thing, you know. It's like, I'm not going to do that. But anyway, okay. That's pretty much all I've got for today. I got to get to school, and yeah, I hope everyone has a great day. Thanks for watching. And any questions before I go? I'm not a veterinarian yet, but I am a vet school student. So, I don't know. I want to talk to y'all. But if there's no questions, then I'll head out. See y'all tomorrow morning, I guess. So, alrighty. 5, 4, 3, 2, 1. Okay, I'm going to end the stream. Thanks for watching, y'all, and see you in the next one.